I want to start by defining a vector. Engineers and physicists will represent vectors in 2 dimensions or in 3 dimensions by arrows. And there are 2 big defining characteristics of this arrow. These are the direction of the arrowhead and the length of the arrow. Mathematicians call these geometric vectors. We call the tail of the arrow where it starts the initial point, and then the tip the terminal point. And vectors are often denoted with lowercase letters that are either bold, so very thick lines, or lowercase letters with arrows on top of them. We say vectors with the same length and direction are equivalent, so here would be 4 equivalent vectors since they are the same length and they do point in the same way. Since we want a vector to be determined solely by its length and direction, equivalent vectors are regarded to be the same vector, even though they may be in different positions. So just like these are in different positions, they are all the same vector. I now want to look at how to define vectors within a coordinate system. So let's start with 2 space. In other words, a coordinate plane with an x and y axis. We think of vectors in 2 space where its initial point is at the origin, and in that case the vector is uniquely determined by its terminal point. Let's say this one is 4, 1. So we can refer to this vector, we'll call it A, strictly by its terminal point 4, 1. If I were to do this one here, we could say this one was 1, negative 2, and we'll call this vector B. So we can uniquely determine these vectors by their terminal points. And we can absolutely expand this idea to 3-dimensional space or even higher. So what if we want to consider a vector whose initial point is not the origin? Let's consider a vector whose initial point is x1, y1, and their terminal point is x2, y2. In this case, we can take the vector that starts at P1 and goes to P2 and write it as a single point, x2 minus x1, y2 minus y1. So we do terminal minus initial. And essentially what this does is it takes our vector and shifts the initial point down to the origin. And we can absolutely expand this to higher space. If I have points in 3 space, then I would do x2 minus x1, y2 minus y1, z2 minus z1. As an example, let's consider a vector that goes from the initial point 2, 4, negative 7 to the terminal point 7, negative 1, negative 8. And I want to write this vector so that its initial point is the origin. So we subtract terminal minus initial, so 7 minus 2 for the first one, negative 1 minus 4 for the second one, and negative 8 minus negative 7 for the third one. So this point would be 5, negative 5, negative 1. So I could define my vector by the point 5 minus 1. Whenever I write vectors in this form where I just refer to their terminal point, this is known as comma delimited form. As an example, we could have a vector that looks like 1, 2, 3, 4. Sometimes we want to write it in what's known as row vector form. In this case, we use square brackets and we just list the points in a single row with no spaces. For our example, we would do a square bracket 1, 2, 3, 4. So this would be our row vector form. And finally, we have column vector form. This is going to be similar to row vector, except for we write everything in a single column rather than a single row. So in this case, we would write it vertically. And reading down, we would go 1, 2, 3, 4. And the choice of notation is often just a matter of taste or convenience. However, sometimes the nature of a problem will suggest a preferred notation. also want to look at what it means for vectors to be parallel. Let's consider these two vectors. They have separate initial points, separate terminal points, and different lengths. However, they do move in the same direction. So it might be natural to think of these as parallel vectors. However, all we care about is length and direction, so we want to be able to shift vectors accordingly. As we discussed before, the actual initial and terminal point don't matter. We can shift them to start at the origin, etc., as long as we know the direction and length. So that makes this a little bit tricky, because I want to be able to shift them together, and now they're no longer parallel because they intersect. Instead, what we think of is collinear vectors. Vectors that are the same direction, but maybe not necessarily the same length. So collinear will just mean that they have the same direction. And a lot of times we refer to this as parallel, even though it is not technically parallel. So when we talk about parallel vectors, what we really mean are collinear vectors.